Hi, our lesson now is about integration. Let's start talking about the integral function. Let's say I have f of x. If we derive f of x, we get f prime of x. So in order to have f prime of x, we derive. So we find the first derivative using differential calculus. But what if we want to return f prime of x to f of x again? The process that makes f prime of x return to f of x is called the antiderivative. Which we can call it as well as integration. Now, let's see how we integrate a given function. Let's say we have f of x to be equal to a times x to the power of n. And we want to integrate f of x. We want to find the integration of f of x dx. We state the dx because I want to integrate f of x with respect to x. Now, if I want to integrate ax to the power of n dx, this is equal to, we take the x value as it is, but what we do is we add 1 to the power. It becomes n plus 1. And we divide over n plus 1. So this becomes as a times x to the power of n plus 1 divided by n plus 1, and we add to this value a constant, we call it c. This is how we integrate. If we have a constant, let's say we want to integrate 2 dx. The integration of 2 is equal to any constant, we just add x beside it. So the integration of 2 becomes 2x also plus c. Let's have a simple example now. This is an example. The point 1 and 3 lies on f of x. I have f of x to be equal to 2x plus 4. We need to find the integral of f of x dx. So now, to find the integral of f of x dx, we first have to integrate. So for the solution, we need to integrate the 2x plus 4 dx. This will give us this is equal to 2x, because the power of 1, it becomes squared, divided by 2, plus 4x, because the 4 is a constant, plus c. Now, to find c, we simply use the coordinates of this point. So I know when the x is equal to 1, the y value is equal to 3. So now, y 3 is equal to, we have x squared, I substitute the 1, so I have 2, will cancel out the 2, so I substitute 1 instead of the x squared, plus 4 times 1 plus c. So I will have c to be equal to, I have, this is 5 on the right hand side, take it to the left hand side, it becomes -2. So my integral now would be equal to x squared plus 4x minus 2, which is the constant. Let's have an example now. The curve y equals f of x passes through the point 1 and 3. The gradient of the curve is given by the function. You know always that the gradient curve of the function is f prime of x. This is f prime of x equals 2 plus x over 3. We need to find the equation of x. So now, f of x, for the answer, f of x, which is the original equation, is simply equal to the integration of f prime of x, because we said that the integration is the antiderivative. It takes the first derivative to the original equation, dx. So now let's integrate f prime of x. So the integration of f prime, which is 2 plus x over 3 dx, this is equal to, the 2 becomes 2x plus x squared divided by, I have the 3 here, and I multiply by 2 because it's, I add n plus 1, I divide over n plus 1, so this is times 2. Exactly as we've seen before. We add here the n plus 1, and we also divide by the value of n plus 1. So in our example, we multiply the denominator by 2, and we add the c. So this is equal to 2x plus x squared over 6 plus c. This is equal to f of x. Now we need to find out the value of c. We use the coordinates of this point in order to find c. We know that when x is equal to 1, the value of y is equal to 3. So we substitute 3 instead of f of x is equal to 2 times 1 plus 1 squared over 6 plus c. So now we have c is equal to, take the 2 to the left hand side, and the 1 over 6 is equal to 3 minus 2 minus 1 over 6. Having the c to be equal to, we can use our graphical display calculator. We go to run matrix. We can use 3 minus 2 minus the 1 over 6 And this is equal to 5 over 6. So now, my final answer, f of x is equal to 2x plus x squared over 6 plus 5 over 6. This is my f of x.